Hello people, welcome to Gurukula. I'm Jai. So today in this video we are going to talk about carrier sense multiple access collision detection, which is abbreviated as CSMA CD. Now without any further delay, let's get into the topic. So whereas in our previous videos we were talking about the access control mechanisms that is getting incorporated in data link layer of the OSI model, out of which we are talking about the types of access control mechanisms, and out of various types of access control mechanisms that we have in data link layer, we are very much particular about the random access protocol mechanisms over here. So in this mechanisms we can see that we are first of all talking about the random access protocol, and we have already discussed the Aloha and then the CSMA protocol. So today in this video we will be briefing about the CSMA CD. So now we will see what CSMA CD is, and we will try to understand what CSMA CD is. As we already know, CSMA stands for carrier sense multiple access, which means that it follows the principle listen before talk. So whereas collision detection comes into the picture based on its mechanism. So based on how CSMA CD works is all because of the collision detection which is happening in the entire protocol over there. So now we will try to understand about the CSMA CD with this simple flow diagram. So let us take for an example that I have a system or a node called as A that is present over here, which is connected to a system called B over here over a shared medium, and I will also assume that this node is also, this particular channel is shared by several other systems like this. So I will call this as A, B, C and D. So all these A, B, C and D are what we call it as the stations which is connected on a commonly shared medium, which you can see over here. Now for our example concern, and then to take our discussions further, let us assume that A wants to send its data to B over here. So based on CSMA CD algorithm, what will be the various steps that will be initiated before sending the frame is what we will be going to discuss in this video. So here let us say that the station has a node. Here in our case we have station A, that is what we will call it as transmitting station. So here the transmitting station first of all initiate a value k is equals to 0, where k is nothing but we call it as k is the number of attempts. So we must have a hard limit on the number of attempts that a station should try before sending any particular frame, because there is no point of attempting again and again on a network which is permanently down. So we should also have the maximum number of attempts which should be predefined before transmitting the any nodes. So as of now, since this is the first time transmission, we will initiate that the k value is equals to 0, and then later on the second stage is I will have to apply any one of the persistence method. So in our previous videos we have discussed totally 3 persistence method. So first one is one persistent method, and second one is non-persistent method, and finally the third one is p persistent method. So all these persistent methods comes under the CSMA, and all these 3 persistence methods will have different behaviors as discussed in the previous video. So if you have not watched the previous video, please do check the link on the top right corner on the I button, and as well as in the description section. So once after selecting any of these persistent methods, the sensing mechanism will follow depending upon this persistence method. So either it will sense continuously as per one persistent method, or it will sense after a random period of time depending upon the n persistence method, or it may send a frame with a probability of p. And it is very much important to understand that the p persistent method is suitable only for the slotted channels are available over here. And then once after selecting any one of the persistence method, then we will have to check and the channel is free or not, and the frames will be transmitted depending upon the 1 persistent, n persistent or p persistent method. Then once after sending the frame, we will have to check if the transmission is done or not. In case if the transmission is not yet completed, we will keep on sending and then receiving the multiple number of frames as depicted in this particular flow diagram. So A station will keep on sending multiple number of frames, and then it will be receiving the multiple number of frames from the receiving stations. Here in our case, receiving station is B as depicted in the example. So in case if my transmission is done, then what will happen? The station A will have to check for if there is any collision that happened to the transmitted frame or not. So in case if there is any collision that is occurred, then if there is no collision occurred, let us take that case first. If there is no collision is detected in the transmission frame, then we can say that the transmission is successful. So all the frames that has been transmitted by A is completely received by the receiving station. So in that case, we can say that the transmission is successful. So this part of the flow diagram is complete. Now let us see what happens if the collision is detected. In case if any frame that is transmitted by station A has occurred or it has intervened any particular collision, then station A will send a special type of signal, that is what we call it as jamming signal. So this jamming signal is a special type of signal which is sent on a network to intimate other stations. It will send a jamming signal. So it is a kind of ICMP type of packet. We will come to know what ICMP is in a later part of the video, but as of now you just understand that it is a special type of signal which is sent to the transmitter and then the receiver, not only to the transmitter and receiver but also to the other stations present in the network, so that they will not send or receive any frames using that particular network. So that is what the purpose of sending a jamming signal on the network. So once the jamming signal is sent, the next immediate step is the value of K will be incremented by 1. So the value of K will be incremented by 1. You might have remembered that before sending any frame, the K value is initiated to 0. Now after the first attempt, we will see that the K is incremented to 1. And after incremented by 1 value, the K value has to be checked whether it has reached the maximum threshold level or not. In case if we have reached the maximum number of attempts, so here in our example the maximum number of attempt is 15. In case if it reaches 15 number of attempts, then there is no point of trying again and again. There might be a permanent failure on the network, so that the transmission has to be aborted. In case if we are not reaching the maximum number of attempts, then what we can do is the algorithm will create a random number R. So R can be any value, any random number which lies between the range 0 to 2 to the power of K minus 1, and where K is nothing but the number of attempts. So when you substitute the values over here, any value can be generated. That value is what assigned to R. And then once R is calculated, and based on the R value, the random amount of time will be calculated for waiting period or back of time. So here TB will be calculated. We will have to wait for an amount of TB, where TB will be calculated by the expression or the relation R times TFR, where TFR is nothing but the maximum time or the average time of the frame. That is what we call it as TFR. So R times TFR will give you the total amount of time that the system has to back off or it has to wait for a period of time. So once after this particular period is over, then it will has to reinitiate the entire process again and again. So this is what the entire algorithm of CSMA CD will work. Now we will try to understand this flowchart in some theoretical perspective. So let us assume that we will try to understand in 3 cases. So what if the channel is free, and what if the channel is busy, and then how long the channel has to be sensed by the transmitting station. So all these 3 questions has to be cleared before winding up the video. So we will see what if the channel is free. It's very simple as that. Let us assume that the node A wants to send its data to node D. So first step what it does is station A first should check whether any other station is sending or not, which is as equivalent to sensing the carrier. And then a station A will measure the energy level of the medium for a short period of time, say approximately it is 100 microseconds. And if there is no signal energy on the medium, it means that no station is sending or receiving the signal on the network, which means that A will assume that, or it will interpret that the medium is idle, and then A will start sending its frame. As simple as that. Now, what if the channel is busy? If the channel is busy, then the signal energy level will not be 0. Definitely there will be an raised energy level when A senses the channel. In case if A continuously monitors the medium until it becomes idle for about 100 microseconds, then station starts sending the frame. However, station A needs to keep a copy of frame in its buffer until it is sure that there is no collision occurred in the network. So this is what happened when the channel is busy. Now, how long A has to sense the channel? Well, that can be addressed in two different cases. What are the two different cases? There is possibility of only two cases. One is my frame may get collided, or it may get received by the station D successively. These are the only two cases. So first case is a successful transmission. So node A or station A is sending some amount of data. Here in our case we will take it as 512 bits of data, and then if there is no collision is happening, then the energy level will not go above the regular energy level, so that the station can ensure that the frame will go through all the stops and it will be successively received by the station D. So this ensures that the proper transmission of the frame from node A to node D, and once after this, a station can stop sensing the channel and then can leave the choice for the other stations. And in second cases, this is a failure case. In case if A sensed a collision when a frame is being sent, in this case both the station should refrain its transmission from sending and then the receiving the frames. So however, after sensing the collision, as we already seen in the protocol diagram or in the flow diagram, it will has to send a jamming signal, and here the jamming signal will be of 48-bit length, and this jamming signal is sent in order to alert the other stations on the network about the occurrence of the collision, so that no other stations will transmit or no other stations will try to send any frame on the network. So this is how the carrier sense multiple access collision detection algorithm will work. So just to sum up what we have seen in this particular video, we can see that we are especially talking about the access control mechanisms, which is working under the layer of data link layer, and then we are particularly talking about the random access methods. So your random access method is classified into several types. So in our previous videos we have discussed about the Aloha and then CSMA in detail, and then the various behaviors of CSMA we have seen already in the previous video. Today in this video we have taken CSMA CD into discussion, and then we have discussed what CSMA CD is and how does it works. And also there is a point to remember that your CSMA CD is a widely used access mechanism technique as far as your Ethernet protocol is concerned. So whenever you have asked for a question that what is an access mechanism used in Ethernet standard, then you can say that CSMA CD is the access control mechanism which is used in Ethernet. And then in the next video we will be talking about what CSMA CA is. That is also another method of access control mechanism which is widely used in wireless scenarios. CSMA CD will be used in the wired environment, and CSMA CA will be used in the wireless environment. So when we discuss about WLAN, we will be talking about why CSMA CD cannot be used in CSMA CA, and all these interrelations will be taken care in the subsequent videos. So with this particular summary, I am stopping my video, and I am going to see you in the next video. Until then, it's bye from Jai and happy learning.